Welcome to video 8.5e, a proof using the side splitter theorem. So here's example 4. Given that XA is parallel to YZ and that angle XAY is congruent to angle XYA, prove this proportion. Okay, so the very first thing I'm going to do is say, hey, it looks kind of like the side splitter. Let's just write down that proportion. So if I were to use a side splitter, I could definitely get WX over XY equals WA over AZ. Just a straight shot of the side splitter theorem. Hey, this thing is very close. The only difference is they've got XA and I've got XY. So again, we've had problems like this before. Maybe there's some substitution that can be made. Oh, I've got these congruent angles, which means this triangle, even though it doesn't look like it, is isosceles. So if I've got these angles congruent, then I'm going to be able to say these sides are congruent. And I will be able to make a substitution of XA with XY. Game over. Let's write down the proof. All right, so I'm going to start with the side splitter theorem. So I'm going to start with the parallels before I can use it. So XA is parallel to YZ. That was given. Based on that, I'm going to do my side splitter theorem, which I wrote down as follows. WX over XY equals WA over AZ, reminds me of Arizona, side splitter theorem. Then what I'm going to do is try to make that substitution. So now I'm going to use this statement here. Angle XAY is congruent to angle XYA. That was given. And then I can get those two sides to be congruent. XY, that length basically equals XA. If angles, then sides. And then all I'm going to do is wherever I've got an XY, just to show you, I'm literally going to do substitution, just like I did over here. So now I'll say WX over XA equals WA over AZ. Substitution, step 4 into step 2. So there you have it, a proof using the side splitter theorem.